Hi, everyone. Welcome to the April Random Review. I'm Deborah Goldenberg. Connie Georgiou and I coordinate this program for Friends of the Library, who sponsors these events. Connie, would you like to say hello?
Hello, everybody. I'm glad you're here.
And our library host today is Mike Hansen, and he'll be moderating the questions at the end of the program. Mike, would you like to join us and greet our audience?
Hi, thanks for joining us today.
Thank you, Mike. First of all, I'd like to let you know that our program will end 5 minutes early today at 12:55 instead of 1 o'clock, because our reviewer has a class to teach and that will give him enough time to sprint to his next location. If you're having any problems with the GoToWebinar platform, please send us a question and we'll try to help you. We're recording this presentation, so if your issues can't be resolved, you'll find a link to the recording in your follow-up letter, and you'll still be able to see the talk. Also, there'll be a link to a more polished version on the random review page on the library website fairly soon. On that same page, you can sign up to receive monthly random review and email announcements, and also find a link to the list of library books related to today's topic, created by our volunteer, Gail Gerdeman. And also, you can register for the 2 remaining random reviews for this year on the same page. We encourage you to submit questions for our speaker during or after the talk by typing them into your question box, and he'll answer as many as we have time for at the end of the program. I'd like to thank our community sponsors, Grassroots Books and Music, Northwest Graphic Imaging, and the Corvallis Gazette-Times. And always a big thank you to the Best Library, and especially librarians Mike Hansen and Bonnie Brzezowski, who have provided us with excellent support over the past 2 years. Next month's review will be on May 11th, when Keith Scribner will review the novel Homeland Elegies by Ayad Akhtar. And now I'd like to tell you that our reviewer today is Dr. Randall Milstein, who has taught at OSU for 32 years. Until very recently, he was the astronomer in residence to the Oregon NASA Space Grant Consortium and teaches astronomy in the physics department and courses in the OSU Honors College and in the College of Earth, Ocean, and Atmospheric Sciences. Here to present his review of The Smallest Lights in the Universe and to tell you a little bit more about himself is Randall Milstein. Randall?
Hey everyone, I'm really glad that you're here to join with me today and the rest of the folks from the library. We'll be talking about Sarah Sager's memoir, The Smallest Lights in the Universe. I'm speaking to you today from inside the astronomy lab here at Oregon State University. You can see all kinds of pictures and things in the background. I originally didn't start out as an astronomer. I originally started out as an artist and took a degree in art before then going back and specializing in science. And through my coursework, through a PhD, studied planetary astronomy. So Dr. Sager's book, she's an astrophysicist talking about star formation and planet formations in other places. So we have a little bit of crossover there. But usually I deal with things here in our solar system, planets, and especially large objects falling from the sky and crashing into planets and causing big explosions. That's my true field of research. And so a year ago or so, the library and actually Tiffany down at Grassroots Bookstores asked if I'd be interested in reviewing this book about it from an astronomer. And I said, sure, I'll give that a try. And I got the book from Grassroots and then left it unread for quite a long time. Just was busy with other things. And finally, I got a call that there was a family emergency and that I needed to fly to Michigan. And so I said, well, I need something to read on the airplane. And I picked up Dr. Sager's book and put it in the car. It was on the way to the Eugene airport at 3 o'clock in the morning to fly to Michigan. And between Monroe and Junction City, I received a phone call that told me not to make the trip because my father had died. And so I turned around and went home, and I put the book up and did not read it or pick it up again for several more weeks, not even knowing what the book was about. I had not read any reviews. I wanted to keep my mind open. And then as I began to read the book, a lot of Dr. Sager's insights, especially concerning the tragedies that befell her life, from the loss of her own father to the loss of her husband, and then dealing with all the surrounding issues with that, became very close to the surface for me. And I could be very empathetic and very thoughtful about the things that she was describing and what she was going through. And especially one passage in the book where she wrote her husband's name was Mike, that Mike left the world the way he had entered it. His last breath was his own. His decision about his time to die. And that was the exact same thing that had happened to my own father. And even my brother and sister who were there with him at the time reported that. And it was very striking for me and very emotional. And there were a lot of things about the book that I really like. Her description of her science and how she does it is very on point for me. And I've heard her TED Talks as well. She's a brilliant speaker. But other parts of the book were problematic for me. But those descriptions of the passions that were going through her and the emotions that were flowing through her at this couple of very significant losses in her life are very powerful. And I think that that's what speaks to a lot of people about this book. This is someone who's had a lot of tragedy in their life. Besides great triumphs, there's a section in the book where she talks about receiving a MacArthur Genius Award. It's a lot of money. And she was almost unable to handle it. She didn't know what to do, with the emotions surrounding this award. We learn later on in the book that there may be a reason for this. It's not addressed until the last 3 pages of the book. And I'll hold off on that for a while. But I really liked her descriptions, especially of growing up in a family where education was highly regarded. I grew up in a home similar to that. And that in one passage on page 14, she said, I've since learned that a lot of scientists have mischief in their pasts, and their particular strain of mischief can be a good predictor of their future chosen field. And I think of, after I read that, I started thinking the colleagues that I have around me, because I teach in a couple different colleges and interact with a lot of different professionals here as scientists. I started trying to predict what kind of mischief they might have had when they were young that ended up having them in the field that they ended up in. And I know that for myself, like I said, I went to art school originally, and that was great. And I graduated, and I was a commercial photographer, and I could take pictures of things and show people what I thought the world was like. But in the end, I was always questioning how it all worked. I really wanted to know how that universe worked around me, how the planet worked, how Mars works. And my curiosity drove me in that direction. And the mischief I had as a kid was I always asked questions constantly, wanted to know how everything worked. And, I'm sure it drove my parents and my great uncle, who was around all the time, kind of bonkers. But those kind of things that she states, these little insights in the book, I think are really super powerful. And they'll come off as one sentence. And I think if you read the book and you search for those powerful insights that she has, that the book really can sing to some people. I know that I've talked to a couple of other people about the book itself, and we've both thought, or all thought, that the writing style itself might be a little unsophisticated in some ways. But like I said, those little treasures are really important. And I found myself putting bookmarkers throughout the book so I could go back and look at those passages again and reread them. Some of them because of the power of them, and other ones because I have to admit I found what it said to be kind of annoying and not reflecting anything necessary for the story. But I think that if you're interested in seeing how someone deals with these situations of loss, and then having a family on top of that, how do you deal with 2 young children who just suffered the loss of their father? And how do you hold that together? Where do you go for support? Do you go to your friends, your colleagues? Do you make new friends? How does that work? If you're feeling alone, in her case, what do you do? Do you try to start new relationships? Do you try to date? Where do you go for that help? And she finds people who stand up and offer to help her and help guide her through things. And I think that's a powerful lesson. A lot of people would otherwise shut themselves off. And why I think this is important in this book is that in page 16, she throws out a little, just a thing, talking about, well, later down the road, I was diagnosed with a problem. And you don't find out again till the last 3 pages of the book. And that is that nearly 50 years old, she finds out that she is on the autism spectrum. And that as you read the book, what at the time seems like possibly bizarre behavior that she reports, or how she deals with the problems seems to some of us who read it, that's not a real good way to go about that, possibly. That it may be because she is unaware that she is on the autism spectrum, and that her antisocial trends in her life, her need to not want to be and make connections with people, that she doesn't understand why. And she's simply telling us the story of what happened in her life. I personally, as someone who read the book and was asked to review it, would like to have seen her identify that early in the book and then try to explain why this diagnosis was responsible for the things that were happening to her throughout her story and her memoir, instead of waiting until the end. But that's my take on it. I'd have preferred to have known that earlier on in the story. I think that one of the other things that struck me in the book was a sentence very near the end. It's actually on page 277, where she states that she had a strong relationship with her father growing up. Her mom was not really in the picture, and so her dad was a physician, raised her. And intellectual things were very important, and her success in school was very important, and she was very smart. But she was bounced around between schools. She could not find a place to fit in for a long time. And so her dad was very instrumental in her life. Later, her husband, her first husband, Mike, becomes incredibly instrumental in her life. Then her department chair after Mike's death, he is able to help her in ways of supporting her science, supporting everything about her. And she has a collection of very powerful postdoc and graduate students. And these men are there to travel with her and her family, to go to conferences and things. And in the end, it's really nice that she's able to find, after a period of time, another man that she connects with and eventually marries, named Charles. But during the story, you learn that Mike, after his death, he had to write a list of things for her so that she knew how to change the light bulbs in the ceiling. Where do you go if you need something? How do you get to the hardware? And he had lists and lists of stuff for her prior to his death, so she knew what to do. And he stayed home while she went out and was during her career, and he was kind of like a house dad doing his own editing from home. Later, when she meets and marries Charles, he falls into the same pattern where he's kind of at home taking care of everything, and she's out with this wonderful career as an astrophysicist. But it's interesting because at that point in the book, she makes a statement that says, "My father told me so many years ago not to rely on any man." And that was kind of taken back by that, where my reading of the story is that she was relying on these men for just about everything. And I'm not sure if she's recognizing that codependency or if that's simply one of the lacks of being able to connect through her autism diagnosis. And so that left me a little questioning in a certain way. But if you're interested, especially in the search for exoplanets and the potential for the search of life in other worlds in our universe and even in our solar system to some extent, the story Dr. Sager tells about how she had to struggle, especially as a woman scientist, in a very white male, highly privileged, science, for getting grants to do research and what she went through, I think is a very powerful story that she tells. And that the successes that she then achieves through that are fascinating and very uplifting, I think, as well. I think if I was a young woman scientist to read this book, maybe a student, that it would show me that there's this path to success and really great success at that, and not to be turned off by what you might think the situation otherwise is. So I think that is a really good part of the story, and to learn why things aren't successful. Why can't we just go look for this stuff? I think that there was a point in the story, I'm trying to remember where I wrote it down here, that, oh, here it is, page 70. She says, national space agencies have their own priorities and agendas set by governments that might rise and fall over a single budgetary dispute or illicit hot room rendezvous. And this is very true. Any of you who have possibly had a science career in the past too, or an academic, that we have grand ideas, but if we can't pay for them, they don't happen. A couple of years ago, under the previous administration, the president at that time was saying, we're going back to the moon, 4 years, going to go do it. And then it was like, well, no, the number one priority is going to Mars. Well, that confuses people in the science community. What's our priority? Is it going to the moon or is it going to Mars? And before that can happen, Congress, in the Senate, they have to pass the budget for that. You can make all the proclamations you want, but if there's no money to pay for any of it, it doesn't happen. And again, yes, we're building the SLS rocket, and we have plans for the Gateway project and Project Artemis on the moon. But again, it takes lots of money. And people forget, when we went to the moon in the 1960s, every year from when President Kennedy made his declaration, 1/4 of our national budget went to that moon mission every year. And we don't have that kind of expenditure right now anymore for these kind of trips, these missions. So when Dr. Sager's trying to make a new satellite to explore for exoplanets, they have to have a grant. They have to be able to find a way to build that, and it takes a while to build the technology to then launch this into space, to make sure everything works. And a lot of people who are not involved in that process don't understand it. And I think she does an excellent job of trying to describe the frustrations, but also the elation of when her mini satellites go up and how they're planning this new technologies. And that's, someone in the field, is exciting to have seen some of those things come to fruition as well. So I think the book is very good in that way of explaining those things. And I think those type of descriptions and stories that she tells outweighs any of the things that I might think of as less than powerful in the story. So in that way, I would highly recommend anybody who is interested not only in astronomy and space, but also in how to deal with certain hardships in life and how at least she went through and dealt with them, to pick the book up and give it a read. Like I said, I read it at a very difficult time for me, and I found her descriptions of the loss of her husband and of her father to be very helpful, and that they left an impression on me, like I said, about how Mike died and how my own father passed away. So in that way, I would highly suggest the book to people. I know they have it done at Grassroots and right here locally, and I'm sure you can find it other places as well. Now, one of the things that I wanted to do before people ask questions, because I think that's really important part of this talk, we want to have time at the end for that, is I want to share some slides with you. When I was talking with Deborah before this all happened, she said, slides are really interesting, and people might want to know about more in depth about what some of the things Dr. Sager talks about in her book. And as a result of that, I threw some slides together for you. And so I'd like to go through them, and then we'll have plenty of time at the end, and people can ask questions either about the book, or they can ask questions about the slides I present, which I think will give people some questions. So let me share my screen with you. Oh, I got to do this here. Let me see. Where's my share my screen thing? I think it's that button right there. Yeah. And I will get my pretty face out of there too. So the big question, and this is the one that Dr. Sager asks in a roundabout way, is, are there other worlds in space like ours? Are we alone in the universe? And this is actually probably the greatest unanswered question in all of human history and all of science. And it's become the basis, of course, in our entertainment world of a lot of speculative and science fiction stories. You see how this works? There we go. So trying to study life in the universe really depends on some key assumptions. And these are known as the Copernican principles, named after Nicholas Copernicus, the famous astronomer. And what this principle does is suggest that the laws of nature, the laws of physics and chemistry, hold true everywhere in the universe, and that our planet that we live on, good old Earth, is not an exception to those rules. That means that while we are unique to live on this planet, we're actually nothing special. Because if life formed on our planet because of certain, say, chemical characteristics, then any other planet that has those same characteristics could possibly have the same chance to support life as well. So then you have to think of this. What's the basic definition of a living thing? Well, NASA actually has a definition of life. This has been around for a while. It says that something that's alive is something that begins an existence. It forms an active existence. It comes into being. It changes and matures over time. That means it can grow or expand in some way. It replicates itself through a well-ordered process. For us, it's usually large molecules, DNA and RNA strands. It can convert fuel into life energy, and it exports a waste. It can adapt to environmental conditions or it perishes. That's the old saying in science, you either adapt, you migrate to an environment in which you can thrive, or you die. Adapt, migrate, and die. And the very last is that the object ends its existence. And interestingly enough, that definition really doesn't apply to viruses or prions on our planet. But at the same time, it defines fire. And interestingly enough, fire only exists on Earth. We don't know anywhere else in the observable universe in which there is fire, except on our planet. Now, as Dr. Sager is trying to find out, are there planets beyond our solar system, our sun? And the answer to that question, and she, of course, as part of that answer, is yes. Dr. Sager has found individually by her research between 750 and 800 planets outside of our solar system, which is an amazing feat. And it's now known that planets around other stars are the norm. It's not an exception to have a planet around another star. But what the question is then asked is, are the systems that we see typical throughout the universe? And do any of those planets actually harbor life? Now, the big question there is, if there is life, would it be life that we would recognize? Well, back in the early 2000s, a grant was given to build the Kepler Space Observatory. And NASA put this together, and its whole purpose was to look for Earth-like planets around other stars. It was launched in 2009, and it was supposed to be a 3.5-year mission, but it did so well and continued to work. They continued to use it till 2013 when it malfunctioned, and then they were able to get it back into commission and send it back useful data until 2018. At that time, it was then retired. Now, before Kepler discovered planets around other stars, we only had our star system, our solar system, as the template for what other solar systems might look like. It's now become very clear from all those planets that have been discovered in these other solar systems that most of them have absolutely no resemblance to our solar system, and that the planets around our star might be an exception to the norm, that they're not what we see other places. Now, the big question that's out there hanging around is, do those exoplanets that are around other stars exist within what we would consider a habitable zone? Because when these planets are found around other stars, they tend to be really big. And this is possibly because of our limited technology. And Dr. Sager talks about this. We can only build space telescopes and the materials we have to a certain limit. We just don't have the technology yet to resolve smaller objects at great distances. And it wasn't until about 6 or 7 years ago that we detected the motions of planets small enough to be like ours, Earth-like. And as of March 2022, last month, astronomers had discovered over 5,000 confirmed planets outside of our solar system. Now, what we're always looking for is a planet that is in what's called a habitable zone, or what is also nicknamed the Goldilocks zone. And that is a place where the heat from the star and the pressures of the world itself, possibly an atmosphere, keep liquid water on the planet's surface in a liquid state rather than being frozen or in a gaseous state. Now, we found planets in those Goldilocks zones, but they tend to be massive, gigantic planets, even bigger than Jupiter, not little rocky worlds like ours. And they orbit very, very close to their star, which is not characteristic of the planets in our solar system. If a big planet like Jupiter or Saturn was close to our star, they would be destroyed. Their gases in them are just way too volatile to be that close to the sun. But the thing is, if we look at our planets, the big ones like Jupiter, Saturn, Uranus, and Neptune, they all have really super interesting moons that orbit them. And it's possible that these exoplanets around other stars would have moons as well. And so maybe it's the moons we need to look at. So the current estimates out there suggest that there are about 400 billion stars in the Milky Way galaxy. And there's up to about 50 billion planets then around the stars just in our galaxy. So if just 1% of those stars was in a Goldilocks zone, or 1% of those planets, were in the Goldilocks zone, that would mean 500 million planets in our galaxy are capable of supporting life that we might recognize. That's a huge number. And then when we think the fact that there are probably, 100 billion galaxies out there in the universe, and each may be between 400 billion to 1 trillion stars in them. And if only 1% of those were in Goldilocks zones, the number of planets becomes just incredible to think about. So in December of 2011, a planet called Kepler 22b was found in a Goldilocks zone, and it became what we thought of as the first habitable planet discovered by the Kepler Space Observatory. And it's a bit, the star which it goes around, 22b, is a bit smaller than our sun. So the habitable green zone, the Goldilocks zone, is a little bit closer. And it's a long ways away though. It's 600 light years away. So even traveling at the speed of light, it would take us 600 years to get there. And it's in the constellation Cygnus, where the star is. And yet this object becomes the smallest known KOI, or Kepler object of interest, in the middle of a habitable zone of a sun-like star. And it is bigger than us though. It's about 2.5 times bigger than the Earth. But this became very interesting. And if any of you are a science fiction fan, you might have seen the show Raised by Wolves on HBO Max. And the planet that is set on is Kepler 22b. Well, since the Kepler Space Observatory is no longer functioning, NASA has got together and got the funds to build the Roman Space Telescope. And it's supposed to launch in 5 years. And it'll be able to use onboard instruments to measure specific kinds of dust that might be around the habitable zone of a planetary system. And it would help us know more about what the chemistry is of those planets. Now, Roman's going to use something called a coronagraph instrument. And this is an occulting disk that blocks out the large brightness from the sun and enables them to try to see any light that's reflected off that dust or off of any small, tiny planets that might be in orbit. Now, if you read The Smallest Lights in the Universe, a lot of what Dr. Sager's research is and what they're trying to do in the book is build a coronagraph instrument and how to do that. They talk a lot about the design and how they tended to do this with 2 different satellites, one acting as the blocker and one as the image maker. But the Roman will have this all in one instrument package. And its field of view, its width of what it can see, will be about 100 times bigger than the Hubble Space Telescope. So that would give them a bigger field of view to be able to research more and more objects. Well, when looking at these other worlds, the big question is to ask then, if we're getting this dust measurements and we're getting some chemistry readings back, which characteristics are important for life to develop on those worlds? Now, astrobiologist researchers suggest that the keys to life on Earth, our planet, are liquid water, the right chemicals, and a steady stream of energy from our sun that's been uninterrupted. And there's indirect evidence that there's liquid water beneath the surface of moons in our own solar system, like Enceladus and Europa. But it's not certain, though, that these are indeed the real things necessary for life, nor is it certain what kinds of life those conditions could be able to support. We're really fortunate here at OSU that we have Dr. Martin Fisk and Dr. Rick Caldwell, who are astrobiologists and are very interested in these questions and teach some really wonderful classes on this subject matter as well. But one of the things we see on worlds in our own solar system is something called a tholin. And this is a term in a package of molecules and things that were first projected by Dr. Carl Sagan back in the 1980s and 90s. And all a tholin is an abiotic complex organic solid. It's just a bunch of chemistry. And if you put some energy into that, it can be a simple relevant gas or solid. And they are basically abiotic complex organic gunk. In our planet, or our solar system, we identified on planets far away from the sun, so they're usually frozen. But it's possible that if you had them in the inner solar system and exposed them to radiation from the sun, especially UV and infrared, that it's possible that these are the chemical building blocks then of the organic matter that we see on the surface. And we see these on Pluto. They're identified on Europa as well, the moon of Jupiter. And so it's very possible that this is the material that may have started life on our own planet in the past. Now, there is a theory out there as well It's called panspermia. And that's the theory that life does exist throughout the universe. And it gets spread around by travelers. In this case, probably meteoroids or asteroids or comets or little tiny planetoids, and that they may have extremophile life forms trapped inside them, and that they just wander around at random throughout the solar system until they land on another planet. And then all of a sudden, if the situation and the conditions are correct, they can become life. We forget that asteroids are about 45% by their mass and their weight of frozen water. And we think of an extremophile on Earth, we have bacteria that lives in frozen glaciers who put out little antifreezes, and then they take sustenance from the minerals that are inside the liquid frozen in the ice, and they survive just fine. So why couldn't that happen in the frozen ice of an asteroid? It's an interesting question. But one of the things we have to think about is if we're out exploring the universe, trying to find new worlds like Dr. Sager and her colleagues, we might actually encounter another living thing. But the life that we, as we know it on planet Earth, might not be the life we find on another world. And again, a lot of that depends on whether the development of the living processes on our planet was a fluke, the byproduct of some unexpected series of events. Or if giving the right situation on another world, the primordial conditions on our planet were the same, maybe life would form there, but it would form based on the environmental response to that world. The evolutionary track would be different. And to avoid prejudgments about this, astrobiologists who are out looking for extraterrestrial life usually qualify their efforts as that search as life as we know it versus life that we might find it. And of course, anybody who's familiar with science fiction movies know that we're always dealing with that, with scary aliens that show up in the shows. But I think this is one of the things that's an interesting question. It's a philosophical question too, because one of the most frightening things we could do is if we went to a different world and we found life there, and it would be life as we know it, but as an alien human life form. I think that would rock the foundation of human thought, philosophical thought, and it would be very, very frightening for us if we would find life that was similar to us somewhere else. Now, we do look for this. There is an ongoing project called SETI, the Search for Extraterrestrial Intelligence. If you're a movie buff, you might have seen the film Contact or read the book by Dr. Carl Sagan. And it involves using large radio telescopes that we point at nearby stars that are similar in size to our sun. And then we listen to for possible communications that would be created by an alien civilization, whether they were trying to send them out on purpose or if it's just accidental broadcasts. This has been going on for quite a long time. It's the 1960s. It lost its major funding source 10 or 11 years ago. That was when Paul Allen passed away. The Paul Allen Foundation paid for this. But Yuri Milner got a hold of this, and he is now financing the search through 2027. Now, one of the things that came out of SETI is a conceptual framework of how it works. And we use the Drake equation. This is simply a mathematical expression where you take variables that you can plug in values for, and as a result of that, try to come up with a calculation. What's the possibility of these exoplanet worlds that maybe would hold an intelligent civilization? And this was started again back almost 60 years ago. Now, what's nice about having a mathematical framework is that then you can think about these big questions like alien life in a scientific way rather than just sci-fi. Because each of the factors you plug in, the variables, can be studied by a scientific method. The bad downside of this is we simply don't have enough information to actually get the true number of variables we might need to have any accuracy in the number that comes out of this. But recent calculations done in Australia suggest that the chances of human beings on our good old planet Earth being unique in the universe is roughly 1 to 10 to the minus 22. That'd be a 10 with minus 22 zeros after it. So it's not likely that while we are unique, that we are not alone. And this is interesting too for us to think about, is that there was some research a couple years ago that suggests there's just a little over 1,000 star systems where aliens, if they existed, could be watching us. It's like a SETI project for them. And these are within 300 light years or so from us. And of those vantage points, they can see our planet. And of those worlds, about 500 or so have viewing angles that would give them at least 10 hours of observational data of our planet whenever we pass between that location and our sun. So there could be other worlds watching us, just like we're watching other worlds. Now, currently the strongest arguments that maybe life exists on those exoplanets are this. There's so many planets out there that statistically some have life-forming environments. Now, if it's life as we know it or life as we find it, we'd have to get there first. In every environment we've ever examined on life, or examined on Earth, life has been evident. We have so many extremophiles here, things that live and feed on arsenic, things that live in complete darkness, extreme pressures, extreme temperatures, little critters called tardigrades who can repair their own DNA even if they're put into a nuclear reactor. These are some incredible things that live here in every environment, and it's ubiquitous on life is in every environment on our planet. And also, again, the laws of nature and the laws of physics and chemistry are universal. So any planet that may be like us should be able to support life as we actually would recognize it in the same way that good old planet Earth does. Now, what would it mean if we discovered that no other life exists in space on those exoplanets? I think that if the answer is there is no other life, would it make us more valuable? But if there is other life out in space on all these vast worlds over the whole hugeness of the galactic worlds, or even universally, we would become part of a connected series of life forms. And I think that would be awesome, but that's just me. But I hope you have some questions. And I think right now Mike is going to field those and have some time to be able to answer your questions then.
Yes, so we have some questions. We have actually one to start with. We have a comment, and I'm going to probably turn it into a question out of it as well. It's audience member wrote, as a layperson, I found her explanations and descriptions to be excellent. I think I understand the transit technique and so much more. As a non-layperson, did you feel that her descriptions of things was accurate? And do you have any comments about that?
Yes, I think that it was very well done. Like I said, I think all the science parts, her descriptions are very strong, and they give it people who have no background in this a really good insight into it. We use transiting within our own solar system all the time. We also refer to it as occulting, not black magic witches occulting, but occulting being when you block something. If my hand's up here and something passes in front of it, this is blocked out. And then when it reappears, I can time that difference when it's blocked and it's not blocked. And the result of that is I can tell if there was something there or not, passed in front of it. And we use this to identify ring systems here in our solar system. Jupiter has rings. A lot of people don't know that. Uranus and Neptune have rings as well. They're just so diffuse. The only way we can see them is if something transits behind them and occults them. So yeah, I think her descriptions, especially talking about discovering exoplanet with transiting, was done very powerfully.
Great, thank you. So another question I have is, how do you feel about the effort and resources needed to allow humans to live on another planet or the moon?
Wow. This is a big discussion point with my students. We talk about this quite frequently. I don't think it's very realistic to think we're going to go somewhere and stay there. Unfortunately, the moon and Mars, places we're talking about going to, don't have atmospheres, and they don't have magnetic fields. And without a magnetic field, you can't retain an atmosphere. Without an atmosphere, you can't block the radiation from the sun. And to go there for any length of time, especially if you're going to be out on the planet's surface, Mars especially, it's a death sentence. If you go to Mars, you die. We already know what's happened to our own astronauts who went to the moon, and what happens to our astronauts in the International Space Station. So to make a concerted effort to remain on a planet or the moon's surface for a long period of time for any one individual is incredibly dangerous. Mars especially has something that, besides the radiation, if you're traveling to Mars and traveling back, which is months and months of travel, and then having to spend 2 years on the surface before you could come back, you are taking a full body scan CT every 6 days worth of radiation. And on top of it, the soil system, or it's not even soil, doesn't have any biologics in it. The regolith on the surface of Mars is full of something called the perchlorate. And it's in the dust, it's in the rocks, so we can't really grow anything there. It would end up in the food, end up in us, and it destroys the human thyroid. So it'd be very, very, very hazardous. And then we have the cosmic ray particles that go through just right through us and destroy our eyes. You know, they can split our DNA and cause problems. And we don't have any protection from those. We couldn't have children on the moon. We could not have children on Mars. Our reproductive system in women is meant for 1 G of gravity on this planet without all that radiation coming at us. So the chances of a survival of an infant would be nearly zero. It's great science fiction, and I love it, and I suspend my disbelief and enjoy a really awesome story like The Martian. But the bottom line is he probably didn't survive very long after he returned to Earth. Sorry if that's a bummer, but
I'm sure for some people it is. So we don't have any more questions at this point. We have time
wow.
for another one or two, but yeah, did you have any last comments you wanted to make?
No, other than, like I said earlier on, I think that the book does a really great job at the science. It tells an interesting story of someone with some very difficult struggles. And then we find out at the end of what probably precipitated those struggles. But as the story is written, her memoir, we're seeing these things happening, and you can start questioning yourself, going, well, why are these choices being made? And then you learn in the end probably what the problem stems from. I would have preferred to see that at the beginning, but it's her story. And like I said, I would recommend anybody who's interested in exoplanets. She's a very powerful speaker. She has done a couple of TED Talks, and you could find her TED Talks online. And a very compelling story. And take advantage of that and learn a little about her. I know I use her as an example in my own classes. We talk about how science and scientists are portrayed in the entertainment media, and how come we're always villains. But I use Dr. Sayer as one of the models of different types of scientists portrayed, and she is the science educator.
Okay.
And, we have the scientist as prophet, the scientist as evil villain, the scientist as mad scientist, but a scientist as educator. People like herself, and we don't think of someone like Stephanie Abrams on the Weather Channel. She's a scientist educating us. Or when we watch public television and see Michio Kaku or Dr. Brian Cox. These are scientist educators. When Anthony Fauci speaks to us on TV, he is a scientist educator. But I use Dr. Sager as one of those examples.
One more quick question came in. If we destroy our own planet, where will we go? 'Cause it sounds like the other planets aren't an option. So
We're not going anywhere. This is where we make our stand, to quote Carl Sagan. There is no other place for us to go to. Not only, even if there was one, how would we get there? We don't have any technology that could take us there. We don't have anything big enough that would help in any ways. And the distances are so tremendous that you'd be generations and generations of people living on a ship before you got to another location. We seem to forget that we adapted and evolved on this planet. Our sensory equipment, our eyes, our ears, how we breathe, how we smell, how we touch things, are all a result of the environment in which we developed. And as I mentioned before, you either adapt, you migrate, or you die. And we haven't got any place to migrate to. We need to treat the home we have as the unique place that helps us survive and be who we are. And understand that without that, we're in trouble. And I mean, we could go into a great discussion about all the different ways that we know that we're in trouble. But the bottom line is there isn't any place for us to go. And it's sad. I mean, great science fiction stories come out of this stuff, but I would definitely say if anyone has the time to read Carl Sagan's statement of the big blue marble, or the small blue dot, I can't remember what the exact thing was, is he has a nice page of things saying about why this planet is the way it is and why our behavior is the way it is. But we have to venerate it as this is all we got. No one's coming to rescue us. There isn't any place for us to flee. And we have to understand the reality of that and treat ourselves a little bit gentler and maybe with a little more kindness, a little bit more acceptance, and maybe we can survive this. But we're in trouble. The carrying capacity of this planet is about 1.8 billion people. There are 7.95 billion people on Earth right now. And that's troubling. And we're wrecking the atmosphere. And we know that historically, with great extinctions, every time the atmosphere gets messed up, everything crashes. People go, oh, the Earth will end. No, it won't. Will end. But the Earth is still going to be here. Sun's still going to come up the next day. Maybe, raccoons or cockroaches or snakes or something will run the planet. But we're pretty sensitive. And there's only one species of us. It's not like a lot of other life forms on this planet that have multiple species. And it wouldn't take much to push us over the edge.
no.
So
Right.
sorry to end on a bummer like that. But, go home and have a slice of pizza and have a beverage, and maybe the rest of the day will go awesome.
Right. Hopefully. Well, I know you have a prior engagement, so I'll invite Deborah and Connie to come back on, and we can say good day. Thank you so much. I wanted to
Thank you guys for your
really
attention. I hope people got something out of it and maybe learned a little. And go and get the book and read it. It's a good read. Bye,
And
everybody.
thank you all for joining us. Thank you for joining us, and thank you very much, Randall, for your interesting talk. And Randall has now disappeared, but anyway, hope to see you all next time. And thanks for joining us.
Thanks for being here. Bye.
Thank you. Have a good day.